Section 4. Conductors. It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how...
Hi, I'm Nathan, your subject matter professional for this learning. I will help you to understand and be able to apply the requirements of the section of the Canadian Electrical Code, Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. This training is divided into topics. These topics build on each other, so a best practice is to review them in the order they are presented. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this Quick Reference Guide to take notes and as a practical job aid for this code section.
Section 4 references IEEE 835, IEEE Standard Power Cable Ampacity Tables. If you are unfamiliar with those calculation methods, you may want to get a copy of that standard. As you know, the Canadian Electrical Code includes many key terms in Section 0 in definitions. The term conductor may refer to individual conductors, conductors contained within cable assemblies, or contained within flexible cords. The ampacities for conductors in Section 4 are maximum values. Depending on the type of installation, the listed ampacities may require correction factors that will reduce the listed values. AWG is a standardized wire gauge system for the diameters of round, solid, non-ferrous electrically conducting wire. The cross-section area of each gauge is an important factor for determining its current carrying capacity. As a wire diameter decreases, the gauge number increases. For example, the diameter of 4-gauge wire is larger than a 12-gauge wire. For neutral and identified, all white or gray conductors can be described as identified conductors. But not all white or gray conductors are neutral conductors. A neutral conductor carries the unbalanced load in the case of a normally balanced circuit. See Rules 4, 0043, and 4. By definition, a neutral conductor of a circuit requires at least 3 conductors in that circuit. However, in the trade, the term neutral conductor is commonly applied to the conductor of a 2-wire circuit that is connected to a conductor grounded at the supply end. Take care in the use of neutral conductor when applying the code.
Time for an activity. Choose your response and then select Submit.
A conductor is a conductive material that is constructed for the purpose of carrying electric current. These include bare, covered, and insulated conductors. Section 4, unlike the other sections of the code, has no subsections. The rules are logically arranged by conductor type to easily find requirements. Wire and cable are covered by rules 4-004 to 4-008. Flexible cord is in rules 4-010 to 4-012. Requirements for equipment wire are in rule 4-014. Neutral and identified conductors are in rules 4-016 to 4-030. Requirements for the colors of conductors are in rule 4-032. And, lastly, requirements for portable power cables are in rule 4-034. It is important to distinguish that conductor requirements covered by Section 4 are for conductors and services, feeders, branch circuits, and photovoltaic circuits. The first photo shows load of consumer service conductors at the load end, termination at consumer service box. The second photo shows a line-side connection to the supply authority's conductors. The illustration shows circuit identification. The Appendix B note to Rule 4-000 also includes the requirements for branch circuits for lighting, appliances, power supply circuits, as well as flexible cords and equipment wires. The requirements of Section 4 do not apply to conductors for other purposes, such as grounding and bonding, unless specified in the code. When sizing a conductor, the code allows two methods: using the tables of the code, or calculating ampacity using the method in IEEE 835, Standard Power Cable Ampacity Tables. However, you must use the method described in IEEE 835 for determining the ampacity of conductors, number 1 gauge and larger, when direct buried or installed in raceway that are direct buried, as well as nickel or nickel-clad conductors. In this module, you'll learn how to size a conductor using the tables of the code. Rule 4-002 specifies the minimum size of insulated conductors that can be used, based on the conductor material. As you can see, insulated conductors shall be not smaller than number 14 gauge when made of copper, and not smaller than number 12 gauge when made of aluminum. An exemption to the minimum size restriction is allowed for flexible cord, equipment wire, control circuit insulated conductors, and cable. Take a look at Rule 4-004. Subrule 1 references Table 1, Table 2, and Table 5C, and selected Appendix D tables. Next, you learn about conductor material and insulation. Before you can apply Section 4 requirements, you need to know and understand the foundational and physical design for conductors. Conductors can be bare, covered, or insulated. The purpose of insulation is to separate the conducting surfaces by a dielectric material, poor conductor of electrical current, or airspace. The insulation has a degree of resistance to the passage of current and to disruptive discharge that is sufficiently high for the condition of use in order. Wire and cables consist of a conductor, or a group of conductors, made of a material that is either solid or concentrically stranded. What are the common cord designs, and when are they used? Flexible cord is used at voltages up to and including 750 volts. Conductor material is bunch-stranded, which is when the strands of the wires are twisted together without a predetermined pattern. Flexible cord is used when flexibility is required, or to minimize vibration transmission, or to allow movement of electrical equipment during its operation. Equipment wire is either solid, concentrically stranded, or bunch-stranded. Its insulation is not designed for exposed field installation. Equipment wire is intended for the internal wiring of electrical equipment, such as the leads of transformers, motors, etc., and for luminous tube signs and ignition systems. Portable power cable is flexible cord that is used at voltages over 750 volts. Similar to flexible cords, portable power cables are normally used in applications where the cables are subject to frequent flexing and where installation is in accordance with CSA M421, use of electricity in mines, and/or the Canadian Electrical Code Part 1. Why have insulation? Select to view a short video. Disruptive discharge is a sudden and large increase in electric current through an insulating medium, caused by failure of the insulating medium under electrical stress, voltage surges. Insulation on a conductor and the sheath of a conductor is designed and tested to withstand the stresses of field installation and conditions of use that it has been certified to. Ampacity tables indicate the maximum ambient temperature on which they are based. Code users must know the ambient temperature of the installation. If the ambient temperature will exceed the value stated in the table, apply Table 5A correction factors.
Time for an activity. Choose your response and then select Submit.
This illustration shows typical markings on conductors. Manufacturer's name and registered trade name. Conductor size in gauge or kilocircular mils and area in millimeters squared. Certification organization and file number. CSA type designation. Conductor material. Insulation temperature ratings. Insulation voltage rating. Other testing conditions. This illustration shows typical markings on cables. Manufacturer's name and date of manufacture by month and year. Certification organization and file number. Conductor size in gauge or kilocircular mils and area in millimeters squared. Conductor material. Number of insulated conductors in the cable. CSA type designation. Insulation temperature ratings. Insulation voltage rating. Other testing conditions. Temperature rating is the maximum temperature the insulation on a conductor is capable of being subjected to from the following sources: the ambient temperature surrounding the conductor, the temperature of the surface it is in contact with, the temperature of the conducting material due to the flow of current, and the temperature of the termination. The maximum temperature rating of conductor or cable is determined by using the CSA designation and cross-referencing that designation with Table 19 based on the conditions of use. The low temperature marking on conductors indicates compliance with a test at that temperature, as specified in the product standard, but does not guarantee safe installation at that temperature. Take care when installing cables at low temperature, which is below -10 degrees Celsius. You should precondition the cable at higher temperatures prior to installation and avoid mechanical shock from dropping the cable. You should not unreel the cable too quickly or bend it sharply or quickly. Consider future movement of the conductor at low temperatures after installation. Time for a scenario. Please read the scenario and follow the instructions to submit your answers. Voltage rating is the maximum RMS or effective value of voltage that the insulation has been designed and tested to be connected to, while maintaining its insulation characteristics, free from short circuits and from grounds. Flame spread rating requirements and definitions are given in the National Building Code of Canada. Rule 2-130, however, requires that insulated conductors and cables installed in buildings are to meet the flame spread requirements of the National Building Code of Canada, or local building legislation. Next is more information on flame spread ratings. Flame spread rating is an index or classification indicating the extent of spread of flame on the surface of a material or an assembly of materials as determined in a standard fire test as prescribed in the National Building Code of Canada. The CSA classification system is made up of the letters FT, signifying flame test, followed by a numerical postscript to identify the test procedure to which the product has been tested. The postscript follows the test procedure's clause numbers as they appear in the standard and shows conformance to that test procedure only. There are 3 markings for wires and cables meeting the flame spread requirements of the National Building Code of Canada, without additional fire protection. FT1 are wires and cables suitable for installation in buildings of combustible construction. FT4 are wires and cables suitable for installation in buildings of non-combustible and combustible construction, and spaces between a ceiling and floor, or ceiling and roof, that may be used as a plenum in buildings of combustible construction. FT6 are wires and cables suitable for installation in buildings of non-combustible and combustible construction, and spaces between a ceiling and floor or ceiling and roof that may be used as a plenum in buildings of combustible or non-combustible construction. For wire, you are most likely familiar with the American wire gauge number. Gauge is used to size non-ferrous conductors and non-ferrous sheet metal. The size range in the code is from number 4-aught, or 0000, the largest, to number 27, the smallest listed in the code. The wire diameter gets smaller as the gauge number increases. For conductors larger than number 4-aught, the code uses circular mill sizing. The size ranges from 2,000 kilo circular mills, the largest, to 250 kilo circular mills, the smallest. In kilo circular mills, the sizing is opposite to gauge, as the wire diameter gets smaller as the gauge number decreases. In case you are unfamiliar with this sizing unit, here are sizing equivalents. Next, you learn about wire and cable requirements. Here are wire and cable requirements in Rule 4-004. The following tables list requirements for wire and cable. Use flexible cord for installations of 750 voltage or less when flexibility and no vibration transmission is required. Rule 4-010 gives the minimum size requirements for conductors and flexible cords as number 18 gauge. The rule also requires conducts in tinsel cord to be no smaller than a number 27 gauge, and for cords for use with specific devices to be no smaller than a number 20 gauge. For ampacity, Rule 4-012 requires the use of the ampacities listed in Table 12. Temperature rating is the maximum temperature the flexible cord is capable of being subjected to. Sources includes the ambient temperature surrounding the conductor, the temperature of the surface it is in contact with, the temperature of the conducting material due to the flow of current, and the temperature of the termination. Flexible cord designations are available in different temperature ratings. Table 11 lists flexible cords with multiple temperature ratings. Users are to verify the cable has the proper temperature rating on the cord for the application before installation. The low temperature marking on conductors indicates compliance with a test at that temperature, as specified in the product standard, but does not guarantee safe installation at that temperature. See Rule 12-4023B for the requirements on flexible cords at low temperatures, which is below -10 degrees Celsius. The Appendix B note to Rules 12-1021 and 2 lists recommendations for handling or installing temperature -10 degrees Celsius or lower. You should precondition the cable at higher temperatures prior to installation and avoid mechanical shock from dropping the cable, and you should not unreel the cable too quickly or bend it sharply or quickly.
Time for an activity. Choose your response and then select Submit.
Equipment wire requirements are in Rule 4-014 and as specified using Table 12. Use portable power cables for installations over 750 volts when flexibility and no vibration transmission is required. For ampacity, Rule 4-034 requires the use of Tables 12A to 12E. Rule 4-0323 requires that where color-coded circuits are required, the following color coding is to be used, except in the case of service entrance cable and when modified by other rules of the code. Here are other color coding and identification requirements of the code. In some installations, a delta connection secondary is grounded to supply single-phase lighting and similar loads, in addition to polyphase loads. As a result, one phase has a higher voltage to ground than the other two phases. Rule 4-0324 requires that this phase be designated as phase A and the conductors be colored red. When a panel board is supplied from a 4-wire delta system, Rule 4-0325 has two requirements. One is that the grounded conductor be located in a compartment that is provided for single-phase connections. The other is that the phase conductor having the higher voltage to ground, phase A, be suitably separated from the barriered single-phase compartment. When the identified grounded or neutral conductors are number 2 gauge or smaller, the identification must be continuous along the entire length of conductor. Identification can be white or 3 white stripes along the entire length. Subrule 4 allows multi-conductor cables, where the identified conductor can be identified using paint or another suitable means such as white-colored tape or heat shrink tubing. This is to be done where the conductors of the cable are accessible and visible, and the markings must not cover the manufacturer's numbering. Rule 4-026 has the same intent as Rule 4-024, but applies to the insulated neutral, identified copper, or aluminum conductors larger than number 2 gauge. In these installations, the identification can be continuous, or the conductor can be labeled or marked in a permanent manner at each end and at each point where the conductor is accessible. This can be done with paint, white colored tape, or white colored heat shrink tubing. Identified conductors shall not be used as a conductor where identification is not necessary, such as one of the phase conductors, for example. Rule 4-030 Subrule 1 excludes armored cable, aluminum and copper sheath cable, and non-metallic sheath cable from this requirement when the identified conductor in these cable assemblies is made unidentified by with paint, color tape, heat shrink tubing, or other suitable means. This must be done wherever the conductor is accessible and visible outside the outer sheath. Subrule 2 allows the identified conductor not to be unidentified when part of these cable assemblies, if the conductor is used as part of a single pole, 3-way or 4-way switch loop. The requirement is that an unidentified conductor is the return conductor. The covering of the other circuit conductors is to show a continuous color contrasting, that of an identified conductor. However, in the case of flexible cords, where the identified conductor is identified by a raised longitudinal ridge, the other conductor shall have no ridges. Free air-rated single conductors, or single conductor cables, are installed so that there can be unrestricted passage of air around the conductors. This dissipates heat buildup when the conductors are conducting electrical current. The space required for unrestricted or free movement of air around the single conductor or single conductor cable is determined by using the outside diameter of the single conductor or single conductor cable. You can then determine the minimum distance from adjacent conductors or surfaces other than the supporting surface. This minimum space, as well as airflow going to this space, is to be maintained throughout the life of the installation. Due to the free movement of air around these conductors or cables for cooling purposes, the code allows these conductors or cables a significantly higher ampacity rating, approximately 50% higher. Due to lack of air movement, significant heat build can occur in the enclosures where these conductors or cables terminate. In these installation methods, the heat dissipation from the insulated conductor is restricted by the installation of an additional layer of material, metallic or non-metallic covering, sheath or jacket, or the surrounding earth when buried. The lack of air movement for cooling purposes, and the addition of other heat-producing conductors without the free movement of air around each for cooling purposes, can increase the conductor's or cable's temperature. To prevent damage to the insulation on the conductors and premature failing of equipment due to breakdown caused by the buildup heat, the code reduces the ampacity rating of these conductors. When determining which temperature column to use, the temperature limitations of the equipment must be considered as per Rule 4-006 when using code tables. For example, the breaker shown is listed for 75 degrees Celsius wire only. This does not prevent the termination of a 90 degrees Celsius wire. It means to prevent undesirable heat buildup. So assign the 90 degrees Celsius conductor to the maximum ampacity for a 75 degrees Celsius conductor. Note that this only applies to the first 1.2 meters of conductor measured from the point of termination. Conductors not terminating within 1.2 meters are assigned the temperature rating corresponding to the CSA designation of the conductor's insulation. For a field-installed insulated conductor as illustrated, use the lowest of either the equipment's termination temperature or the conductor's insulation temperature. In the example shown, the conductor beyond the first 1.2 meter of conductor coming from the termination is sized as a 75 degrees Celsius conductor based on the conductor temperature rating. When an equipment termination temperature is not listed, the code defaults to the following: 60 degrees Celsius for equipment rated 100 amperes or less, or marked for number 1 gauge or smaller conductors. 75 degrees Celsius for equipment rated more than 100 amperes, or marked for conductors larger than number 1 gauge. Note that all circuit breakers are tested to a 75 degrees Celsius maximum. There are 6 steps to determine which installation temperature column to use. Click and move the slider to see and learn how. There are a number of rules in Section 4 that guide installation correction factors. These factors are determined by the installation conditions and are applied to the ampacity table that is being used for the particular installation. These correction factors reduce the ampacity of the conductor or cable to prevent damage from higher levels of heat. Click or move the slider to see and learn about correct factors. Time for a scenario. Please read the scenario and follow the instructions to submit your answers. For medium voltage cables, shielded cables are rated 5 kV to 46 kV. Sizes are number 2 gauge to 1000 kilocircular mils, as specified in tables D17A to D17N for the configurations described. The conditions are described in table D17, or as calculated by IEEE 835 calculation method. Next is an example of how to size a conductor. In the practice, you are given a scenario with some information already identified. You use code requirements to determine additional information to size the conductor correctly. There are a total of 6 steps. Ready to get started? Step 1 is to identify the table of the code to use. There are 4 pieces of information you need for this step. Do you have enough information from the scenario to complete step 1? Review code rules to determine or find other information. Step 2 is to determine the conductor's insulation temperature rating using the correct table of the code, either table 11 or 19, and using rule 4-006. There are 2 pieces of information you need to identify. Use the appropriate table and rule 4-006. Step 3 is to apply the correct load type, determined by applying Rule 8-104. Step 4 is to determine any installation correction factors. Step 5 is to determine the minimum size of the conductor using the information from steps 1 to 4. Step 6 is to determine if a voltage drop calculation on the selected conductor size is necessary, based on Rule 8-102. Time for a scenario. Please read the scenario and follow the instructions to submit your answers. Table D17 has the conditions of use for tables D17A to D17N, which are tables and diagrams of ampacities for shielded cables rated 5 kV to 46 kV. The ampacities listed in cables D17A to D17N are valid only for the configuration shown and the conditions specified in table D17. A change in any one or more installation conditions or cable construction will result in a change in maximum conductor ampacity. Click each box to learn more. Rule 4-018 explains sizing the neutral conductor. The neutral must have sufficient ampacity to carry the unbalanced load. The maximum unbalanced load is considered the maximum connected load between the neutral and any one ungrounded conductor. In this example, we see 320 amperes of single negative phase loads on L1 and 360 amperes of single negative phase loads on L2. Under ideal conditions, the unbalanced load is 40 amperes. However, the maximum this neutral could carry is 360 amperes. Thus, a neutral conductor capable of carrying 360 amperes would be required.
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section. You have now completed the learning on the main concepts and requirements of this code section. Next, you will take the open book quiz through the link on the course page.